Hello! Did you know? Sharks and rays have a sixth sense. They use electromagnetic fields for the detection of prey under the sand, finding a mate, and navigation over long distances by using the Earth's magnetic field. Offshore wind is a reliable source of renewable energy, but the cables needed to transport the generated power to shore also generate electromagnetic fields. With the planned expansion, more cables with increasing capacity will be placed in the seabed, and these cables produce a similar level of electromagnetic field as used by sharks and rays. We don't really know what the effects of offshore wind-generated electromagnetic fields are on sharks and rays. When fish come across a cable, they might sense the electromagnetic field, but what happens then? This lack of information forms a concern voiced by NGOs, the fisheries industry, and policymakers. And research suggests that behavioral responses range from attraction, confusion to deterrence, but too much remains unknown. So, in order to learn more, we're going to conduct research within the elasmopower project. Firstly, we're measuring actual electromagnetic field levels under different circumstances. This is important as the levels of electromagnetic field generated are directly linked to the amount of power transported through the cable, which in turn is a result of the wind speeds. Then, in a lab, we're looking at the behavior of common shark and ray species when exposed to EMF. We hope to determine the dose-response relationships. We then want to see if the findings in the lab correspond with what we see in the field using underwater video recordings around the cables. There may also be positive effects of offshore wind farms. As bottom trawling is not allowed, there's less bycatch and more habitat to deposit eggs. But are sharks and rays really using this opportunity? Or are electromagnetic fields making this sanctuary less attractive? Summarizing all that we've learned, we want to be able to answer the question, are electromagnetic fields from offshore power cables a problem for sharks and rays? And if that is the case, which mitigation measures are optimal in relation to efficiency and costs? If we can answer these questions, our research can help in mitigating effects. It can support policymakers in optimally planning new offshore wind farms and thereby contributing to a safe, sustainable energy transition. The outcome of this research has interested parties from industry, government, science and NGOs. They are united in the elasmopower consortium, contributing and committed to meeting the research goals. Want to learn more? Just let us know.